Artificial intelligence is rapidly evolving. Agentic AI represents a significant leap forward. This new type of AI goes beyond simple task execution. Agentic AI systems can act independently. They can make their own decisions to achieve specific goals. Several factors drive the rise of agentic AI. Data availability is one crucial element. Powerful algorithms are another. Increased computing power also plays a vital role. These advancements have enabled the development of sophisticated AI agents. These agents can interact with their environment. They can learn from their experiences. They can adapt their behavior accordingly. This new level of intelligence has far-reaching implications. It promises to revolutionize various industries. Agentic AI is poised to transform our world. From self-driving cars to personalized medicine, its potential applications are vast. As we delve deeper into the realm of agentic AI, we will uncover its true power and impact. One of the key drivers behind agentic AI's capabilities is the use of learning from demonstrations, or LFD. LFD allows AI agents to learn by observing and mimicking human experts. This approach is particularly valuable in scenarios where explicit programming is challenging. Consider training an AI agent to drive a car. It is difficult to articulate every rule and nuance of driving. With LFD, the agent can learn by observing a human driver. It can then generalize from these demonstrations to handle new situations. LFD significantly accelerates the development of agentic AI systems. It enables them to acquire complex skills and behaviors more efficiently. This approach reduces the need for extensive hand coding. It paves the way for more adaptable and versatile AI agents. As LFD techniques continue to advance, we can anticipate even more impressive feats of agentic AI in the future. Agentic AI systems exhibit several key characteristics that set them apart. Autonomy is paramount. These agents can operate independently without constant human intervention. They can make decisions and take actions based on their own understanding of the situation. Adaptability is another crucial trait. Agentic AI systems can adjust their behavior in response to changing environments and objectives. They are not limited to pre-programmed responses. They can learn and evolve over time. Goal-oriented behavior is inherent in agentic AI. These agents are designed to achieve specific goals. They can plan and execute actions to reach their desired outcomes. They can also monitor their progress and make adjustments as needed. Finally, real-time decision-making is essential. Agentic AI agents operate in dynamic environments. They must be able to process information quickly and make timely decisions. This ability is crucial for tasks like autonomous driving and financial trading. Section 4. Constructing the agentic AI system. An agentic AI system is typically composed of several key components that work together seamlessly. The perception module acts as the agent's senses. It gathers information from the environment through sensors or data streams. This information is then processed and interpreted to create a representation of the world. The reasoning engine is the brain of the agent. It uses the perceived information to make decisions and plan actions. This module often employs sophisticated algorithms such as decision trees, state machines, or deep neural networks. The learning module enables the agent to adapt and improve over time. It uses data from the agent's experiences to update its internal models and decision-making process. This module is crucial for enabling the agent to handle new situations and optimize its performance. The action executor carries out the decisions made by the reasoning engine. It interacts with the environment by controlling physical actuators or digital interfaces. The memory module stores the agent's knowledge, experiences, and learned information. This module allows the agent to retain information over time and use it to inform future decisions. Section 5. Multi-agent systems in action. Multi-agent systems represent a fascinating subfield of agentic AI. In these systems, multiple AI agents interact with each other. They collaborate to achieve a common goal. These interactions can be cooperative. For example, a team of robots working together in a warehouse. They can also be competitive, such as in a trading simulation where agents try to maximize their profits. Let's consider 3 basic examples of multi-agent systems. 1. Traffic management. Imagine a city where traffic lights are controlled by intelligent agents. These agents can communicate with each other. They can adjust their timing dynamically to optimize traffic flow. They can reduce congestion and travel times. 2. Disaster response. In a disaster scenario, a swarm of drones equipped with AI agents could be deployed. These agents could coordinate their efforts to search for survivors. They could assess damage and deliver aid. 3. Personalized education. An educational platform could employ AI agents. These agents could tailor learning materials to individual student needs. They could provide personalized feedback. They could adapt the learning pace based on student progress. These examples highlight the potential of multi-agent systems. They can address complex challenges. They can improve efficiency. They can enhance our lives in numerous ways. Section 6. Agentic AI, reshaping our world. Agentic AI is poised to revolutionize various industries. In customer service, AI-powered chatbots and virtual assistants are already transforming how businesses interact with their customers. These agents can provide instant support. They can answer questions. They can resolve issues efficiently. In the supply chain, agentic AI can optimize logistics, inventory management, and demand forecasting. This can lead to cost savings, increased efficiency, and reduced waste. In finance, AI agents can analyze market data, identify investment opportunities, and execute trades with minimal human intervention. Autonomous vehicles represent one of the most transformative applications of agentic AI. Self-driving cars, trucks, and drones have the potential to revolutionize transportation. They can improve safety, they can reduce traffic congestion, they can increase accessibility. As agentic AI continues to advance, its impact on our world will only become more profound. It has the potential to reshape industries, redefine work, and solve some of humanity's most pressing challenges. By embracing this transformative technology responsibly, we can unlock a future of unprecedented possibilities.